All right, so we're going to do multiplicative inverses and matrix equations. So if you notice from your agenda, you have another quiz next Tuesday, and that's going to cover your determinants, multiplicative inverses, and your matrix equations. But these today really work very similar. So I'm going to jump in, and this is your second day of section 2.5. Matrices, right? Again, they're not hard either. So I'm going to call this one 2.5 day 2. So this is section 2.5. I'm going to call it day 2 because we're extending from determinants. And what you're going to be doing is finding what is called a multiplicative inverse. So multiplicative, long word, inverse. You can abbreviate if you'd like. And matrix equations. And we're going to do matrix equations. Little formulas. And you're going to put this back together with your multiplication as well. Okay. All right, so first and foremost, we are going to do inverses for just 2 by 2s by hand. Okay, we're not going to go any bigger. So for a second order 2 by 2 matrix. Okay, when we get to the 3 by 3s, you can use your calculator, which we will get to. So for the second order 2 by 2 matrix. All right, so here is your formula. To say you are given, I'm going to keep this just algebraic, a matrix, and let's go A, B, C, and D, just like before. So given that, then your inverse, and you've seen this notation before. So A inverse is equal to 1 divided by, and then I'm going to do the determinant of this matrix right here. So I'm going to do this notation, which again means determinant of that matrix. I'll write this out in words after too, because I think sometimes that's helpful. And then multiplied by, and there is a little pattern to this. So what you're going to be doing is you are going to take your original matrix. You are going to flip the major diagonal. So A goes there, B goes there. And then what you're going to do is you are going to negate the C and the B. So I'm going to do negative C and negative B. Okay, and again, this, in case you forgot, this stands for your determinant. So that's how that's going to be abbreviated. Okay. So you take your original matrix, you're going to flip along the major diagonal, negate the minor diagonal. I'll write that. So flip the major, negate the minor. So flip major, negate minor. If you remember that, you'll never get these wrong. And then one other thing to mention. This is only possible if your determinant is not 0. So your determinant can never be equal to 0. Because can we do 1 divided by 0? No. Again, most of the cases you're going to see are going to be possible, just like that multiplication that you did. All right, so I'm going to give you your first example where we're going to find the inverse. So I will say number 1, and I want to find the inverse. Find the inverse. It's nice because it does always follow the same procedure. So inverse notation looks like this. Okay, so let's give you a matrix. So I'm going to call it matrix A. And 2 by 2 again. And I want to go negative 4, 2. And then 3 and 5. And what we want to do is we want to find the inverse. So what is the formula? The formula for the inverse is 1 divided by the determinant. So to do the determinant, it's entirely up to you. You can do the work on the side somewhere, or you can just place it in and do it in your head. So my determinant would be -20 and then -6. And I'll do this. This is your determinant. And then you're going to take that number and we are going to multiply it by our matrix. So we have to apply the pattern. So I am going to switch the major diagonal. So the major diagonal becomes 5 and then -4. And then I'm going to negate the minor. So -3 and -2. Okay. You're really almost done. So this is going to be equal to -126. And then this is times 5 -2. And then -3 and -4. And the reason that these are relatively quick when you find the inverses is this is just scalar multiplication. Did you have to show any work for scalar multiplication? No. It's only the matrix multiplication that requires work. And that's where we pull the matrix equations that you're going to do today as well. So all I have to do is multiply this now. It's up to you. If you want to reduce it, you can do that too. So my answers, I am going to have -126 times 5, so that would be -526. Next entry going right across, I would have -2 times -126, which reduces to 113. And next, I have -3 times the -126, so that would just be 3 over 26. And last, I have -4 over the -126, so divide by 2, this would be 213. Done. How's that? Pretty manageable? You have to reduce it? You should reduce it. Yep. You definitely should simplify as much as possible. Good question. All right, let's do one more inverse. And then again, it's going to be the same size. So I want to do one more inverse. Again, nice little formula that you just have to remember. So find the inverse. And let's go A again. So I have matrix A, and this time this is equal to, I'm going to read, bless you, 3 -8, and then -1 and -2. And then again, just do your formula. So this is equal to 1 divided by the determinant. So that's how the 2 days kind of mesh together. So my determinant, I am going to do 3 times -2, which is -6, and then minus, because it's always minus, and then -8 times -1 would be 8. So there's that work. And again, that's your determinant. Just note to self there. And now you're going to do your flipping. So you're going to take your 2 by 2 matrix. You are going to flip your major diagonal and keep the signs the same. So this becomes -2, +3. And then I'm going to negate my minor diagonal. So the -8 becomes a positive, and the -1 becomes a positive. And I'll just keep going. Again, these are easy because they're. -14 is fine. Yep. So then I have -1 over 14. And then we're going to go right through this and please reduce them. 8 and then 1 and 3. And again, these are quick because this is just your scalar multiplication. All right, so answers. I have 2/14 reducing down to a 7. I have -1/14 next. 8/14 is going to reduce to -4/7. And last would be -3/14. How are the inverses? Good. Again, we only do 2x2 inverses just by hand. Once we get to the 3x3, that's just something you can use a calculator for instead. So now we take this concept and we extend it a little bit further. So we're going to use it to solve a matrix equation. Now, a lot of this notational, a lot of the notational things you do have to write. So I'll kind of make sure you know what you can skip and what you need to make sure you include. So these are called matrix equations. And this is how you can solve systems. So you did substitution elimination on your quizzes yesterday. Here's another alternative. The matrix equations. I'm going to give you, and again, it's going to look like what you did yesterday. 2x minus 3y is equal to -1. And then I'm going to go -4x and plus 5y is equal to -18. Okay. Would you guys agree this is something you would have done elimination with yesterday? Okay, so now we're going to solve it using a matrix instead. So when you get to a test in the quiz, it is going to specify that you have to solve it using matrix equations. The first thing I do is I write a matrix with all my coefficients. So I am going to go 2, -3, -4, and 5. And that's going to be my first coefficient matrix. Here's my matrix with the variables. So I go x and y. And then I set this equal to -1 and -18. That has to be written. Next step that we're going to do here is the same exact as what you did about to find the inverse. So I'm going to continue. And I'm going to do 1 divided by the determinant. So my determinant is going to be right off this matrix. So it's going to be 10, and then minus, and then 12. Same thing as you did for your inverse. Now I'm going to flip it again. And then you'll have the new part after. So I take it and I flip it. So it becomes 5 and 2. And then I negate it. So +4 and +3. But now what changes is you have this matrix. So that needs to be included as well. That's why this becomes a lengthier process. So I'm going to continue. And I have a -1/2 here. And then next, I have 5, 4, 3, 2. And multiplied by -1 and -18. So you're going to end this process with scalar multiplication, which is that one. But before you do the scalar multiplication, you have to do the matrix multiplication. You got to multiply those two first. So this matrix is a 2 by 2. This matrix is a 2 by 1. Is the multiplication possible? Yes. Our resulting matrix is a 2 by 1. So I have the -1/2 that I have to include. And then I'm going to have 2 rows, 1 column. Again, just trying to write this big so you have places for your work. And again, this is where everything starts to come together. So I need to multiply. First thing I'm going to do is row 1, column 1. And then I'm going to do row 2. column 1. All right, so I have here a 5 times a negative 1 plus 3 times negative 18, which is equal to, what is it, negative 59? Yep, so negative 59. And then next, I'm going to do 4 times negative 1 plus 2 times negative 18. So I have negative 36, and I have the negative 4, so this one is equal to negative 40. Just making sure we don't make little mistakes in the middle there. Now is it fast? Yes. Now you are at scalar multiplication, and you're essentially done. Now here's how you have to write this answer. I'm going to do the 59 over 2. And then this is obviously going to simplify to just give me 20. And you must state that that is equal to X and Y. Okay? So that is an alternative way to arrive at the same solutions as you did with substitution, elimination, and graphing. So it's applying a matrix equation instead. Okay, I want to give you one more of those at least. Combined a lot of content together all at once. As long as you practice it, you will get good with it, but there's a lot of steps. Okay, so number 2. Same directions. It's going to say solve, and you must use matrix equations. No substitution, no elimination, no graphing. So this is matrix equations. So I'm going to go 4x plus 3y, I made your life a little easier, equals 0. And then I want to go 2x and minus 6y is equal to 5. So you are first going to write out what we call your coefficient matrix, followed by your variables. So I go 4, 3, 2, negative 6, multiplied by the variables I used here, which was just X and Y, equal to 0, 5. And now you're going to pull the process that we made use of for your inverses and get this started. So I do 1 divided by determinant. So 1 divided by my determinant here. You want to do this off to the side. You don't have to keep writing things. I understand. So this determinant would be negative 24 minus 6, which is equal to, yep, negative 30. Perfect. So there, I did that on the side, and now I'm going to just throw it in here. Now you take your matrix, and you're going to flip your major and negate your minor. So flip the major, negate the minor. Then you're going to pull the 0, 5. And again, that's where your matrix multiplication comes into play. Okay, so I've got that so far. Next step. So I have negative 1/30. And you're going to notice that these are the same dimensions that you had above. So is multiplication possible? Yes. So it's a 2 by 2 and a 2 by 1. So my resulting matrix here, again, is a 2 by 1. So I need to do here row 1, column 1. Bless you. And row 2, column 1. So I have row 1, column 1, row 2, column 1. And again, this one's easy because you have a 0 in there. So I want to do negative 6 times 0, or you can leave that off. And then I'm going to have plus the 5 times the -3. All right, so I have -1/30 multiplied by -15. All right, and then you're next. I have row 2, column 1. So I'm going to go -2 times 0 plus 4 times 5. And that is equal to just plain 20. And lastly, all right, so -1/30 times -15 would reduce down to, yep, 1/2. Okay, to get fractional answers, just like you did yesterday. And then -1/30 times the 20, so divide them by 10, and we have -2/3. But you need to state that this is equal respectively to x and y. So x and y. Okay. How do we feel with the two matrix equations? Do you get the procedure? Okay, I need an answer from you guys if you want another one of these or if you want to start homework and try them. Homework, perfect. So homework, you're pulling out page 103, 27 to 39 odds. Again, the inverses are quicker than matrix equations, but the procedure is essentially the same. Quiz next week on Tuesday. I believe your problem should already be linked right on your Google Doc, so feel free to make use of that.